Get started again, continuing the stream on UTM framework.
Okay, so welcome back, and if you're at the door, just tell your colleagues to get in here quickly because some more fascinating and interesting presentations are about to begin. And again, in the spirit of getting out of the way of these gentlemen, I'm going to just launch into it. And so we're now going to continue our UTM presentations. Each speaker is going to have 25 minutes for their presentation, and then it's after this session, so after these four gentlemen have spoken, we'll invite the other panelists back up, and we'll have a round of questions and answers. Still looking for you to email us your questions. We've got a few. We'd like to get a few more. So without any further ado, I'd like to introduce Larry Lay. He's the portfolio manager at the Boeing company in their integrated airspace and operational efficiency solutions area, which is part of the research and technology airspace operational efficiency group. I think I got that right, I hope. In this capacity, Larry delivers Boeing significant manned and unmanned aircraft performance knowledge, onboard and ground communication, navigation and surveillance technology, systems expertise, and airlines operations understanding and support of air traffic management modernization initiatives and programs globally. So, Larry, welcome.
Thank you very much. Good afternoon. Thank you. Let me begin by thanking ICAO for the invitation for us to present today. On behalf of a very excited Boeing team that wasn't able to come with me, they send their thanks as well. As a global company, we tend to do things on a big scale, and in the development of this white paper that we provided, that is no exception. We had fantastic support from representatives out of Boeing Australia, Jeppesen in Denver, as well as in Germany, in situ, our UAV platform subsidiary in Washington State, as well as in Costa Mesa, California, our research and technology organization in the U.S., Mesa, Arizona, Philadelphia, Seattle, and in Madrid, Spain as well. So on behalf of them as well, I would like to thank the ICAO organization for this opportunity. This is a great venue to talk about the capabilities that the Boeing company has been involved in developing over the course of the last 7 to 10 years. What I will review today will be a focus on our safety, snapshot of our relevant capabilities that are TRL 5 or better that are relevant to this issue. Thoughts on key UTM areas of interest, and at the end provide some recommendations for the group's consideration. Our efforts in this space reflect a One Boeing solution that leverages our unmanned air vehicle RPAS platform expertise from in situ, our Jeppesen pre-flight and in-flight planning, global nav data, weather, NOTAM management system expertise, corporate commitment maintaining safety in the global airspace, and our engagement with regulators and air navigation service providers worldwide to shape an environment of integrated manned and unmanned flight. Like all of us here, safety is a hallmark for the Boeing company, and it is a top priority as we look at solutions that could be employed in this area. It's an enduring value that has helped the company through its 100-year history, and in our intent to continue to actively engage in this activity to ensure that it is responsibly introduced as part of this effort. Autonomous products and capabilities are augmenting human capability and changing our world. We will leverage our knowledge of autonomous systems from the seabed to space to shape this new frontier. We are on the leading edge of technology and seek partnerships with regulators, industry, and academia to set the direction for autonomy, the integration of manned and unmanned systems into this global airspace. And as we look at this, and as you can see the chart of the legacy of our manned platforms going back to 1916, and then the most recent unmanned systems, and then in the very lower right-hand corner, a photo of our vision of a global unmanned global freighter in the 2030 timeframe. You can appreciate our desire to ensure that safety remains a key hallmark in this activity. It is an activity that we drive into our airplane platforms, into all of the systems that go on those platforms, into the employment of systems design, the ConOps that will be used for unmanned systems, training, and technology. It's all about maintaining NAS safety with the introduction of UAS, small UAS, and UTM as they enter service. Key enablers that we currently have as products that are the result of the investment that we have made over the past 10 years or so are the following, and I'll walk you through each of these, but they're driving our engagement. It all started with our ScanEagle platform, which recently accumulated over 1 million flight hours and has recently established commercial revenue services in Australia. For the ScanEagle, it's almost back to the future, because this system started initial operations back in 2001, and helping commercial fishermen identify schools of fish in the Pacific Northwest. Most of the, with the war on terror, we supported, of course, the ScanEagle in operations, but now have begun to leverage this significant experience that we have in the development of both concept of operations and safety case to work with regulators to help introduce commercial revenue services of UAS platforms. In Australia, we've worked very closely with the government of Australia, with the government of Queensland, with universities in Queensland, and other partners to develop the Axon system, which is currently at a TRL, Technology Readiness Level 8. It is jointly developed in Australia, as I indicated, and it's been brought to the United States for testing with the FAA at Mississippi State University. It provides the operator with a real-time data regarding UAS location and other manned aircraft operating in an airspace of about 15 nautical miles. And we're currently looking at extending this capability to a 20-mile range. We're also beginning to look at the detection of smaller platforms that could be detected in that airspace. Another solution that we've developed that through our in situ activity is the Anexa Solutions. This is a remote sensing and information delivery system that provides operators the professional aviation tools to control UAS operations. The Anexa system is also at a TRL 8 level, and it is employed actively with the Axon system, and as Axon, it has also been brought over to the United States. These three capabilities are all integrated. The Axon and the Annexus systems are not dependent upon the ScanEagle system. We can integrate other UAV platforms into their operational capability. Having said that, these three systems were deployed recently in South Texas in advance of Hurricane Harvey, and we worked collaboratively with the FAA, with the counties in South Texas to stand up a TFR and to deliver post-hurricane services to help clear the port of Houston. As part of this activity, we were also responsible for the segregation of manned and unmanned aircraft that were flying in this particular region. That extended from Corpus Christi all the way up to Houston, a significant area. It reflects the advancements that we seek to make in employing this technology in real time for customers today. Could you click on the graphic, please? So this technology is called our SAFE technology for safe autonomous flight emergency. It is built on a couple of algorithms. Boeing has patented it based on the application. And what it does is that it helps unmanned air systems identify emergency landing sites so that they can land safely in the event of an emergency. Operators are obviously using this capability, would be using this capability to employ beyond visual line of sight operations. We're leveraging Jeppeson's global ARINC 424 nav data database to be able to integrate this kind of capability into a system that is now being integrated into Annexa and into the Axon product suite. And you can see here a little bit of a description of the algorithms that are employed to use this system. I'd like to switch a bit here and talk about the experiences that we've had in Australia, in the United States, and in Europe regarding the application of UAS and small UAS operations. In Australia, we have over 7 years of expertise in undertaking beyond visual line of sight operations. We have worked with Australian resource companies since 2015. This partnership has been obviously predicated on collaboration with CASA, the air regulator in Australia, as well as with Air Services. We're currently operating in a range of about 50-kilometer range at about 3,000 feet. It reflects really the integration of what we've done with Annexa, with the Axon, to bring this capability in to provide a real-time airspace situational awareness capability, airband, communications extensions, and detect and avoid capabilities in an area that will ultimately be, when we start our commercial operations next month, of about 123,000 square kilometers, or in other words, about the size of the state of Mississippi. This system reflects really the partnership that we seek with governments, with universities, with industry, in order to, let's say, establish the frontier, push the boundaries of the frontier, and really begin to identify where these capabilities can be employed. Next month, as I indicated, we're going to be initiating drone revenue services with a oil company, and we'll be managing the whole infrastructure of pipelines that extend for that 123,000 square mile area. It's also, we're looking at the integration of Jeppeson's nav data and pre-flight and in-flight planning activity to further create a more robust capability that is now employed on a daily basis in manned flights. So in the before I jump to the U.S., let me just briefly mention we do have a project that will be underway next month in Europe as part of the Single European Sky Advanced Research Project. It is led by CRIDA, the R&D division of NIAIR, the Spanish air navigation service provider. It is similar in terms of really providing a portal capability to UTM-related operations, and it leverages our Jeppesen product category capabilities in a portal environment that's cloud-driven, scalable, and with a range of services that enable safe operations of UTM. That will be a 2-year program. The other project that I'd like to talk about is the Land-Sea project that we are collaboratively working on right now with the FAA. And we were asked, along with a number of other companies, to look at automating the manually intensive and costly authorization and notification requirements that the FAA is currently managing as part of their small UAV introduction to into the National Airspace Initiatives. It ensures time-critical information, such as news accommodation, emergency response. It integrates with air traffic operations, and it will be in a position to integrate with the myriad of different FAA systems to enable safe flight operations. It is secure, it's scalable, it's safe, and it would be all focused on the delivery of small UAV related activities. And I indicated we'll do this, our initial demonstration next month, and we look forward to that. Let me just explain a little bit about the chart itself. You see the solid yellow line reflects the original flight plan of a drone, of a small UAV. You can see up on top a couple of white lines and below a couple of orange lines that the white lines reflect other UAV operations that do not impinge on the proposed flight plan. The orange flight lines do reflect a conflict. The yellow square reflects a geofenced area, and the blue wavy lines signify winds. And so the dotted line is the automated capability that our system has to allow the small UAV to execute a flight plan that steers clear of other operators in that particular environment while taking advantage of minimal wind resistance in order to perform the flight in the most effective manner. We believe that this project represents really the first step to a national system. So those reflect some of the demonstrations that we've been in over the course of the last few years using the technology and the products that we have as a company. What I'd like to do in the next few minutes is to talk about some of the issues that we were asked to consider with regards to networks, registration, and geofencing. Let me start with the network piece. We were selected by NASA Glenn to undertake a project on their behalf called the Safe Aircraft Systems Operation, SASO, and the Remote Scanning Project. And basically, this is a contract that currently is underway that we are executing. We are undertaking an assessment of the global communications network. That includes data links and applying these networks to RPAS and to small UAV operations in order to enable that the communication links for the operations of these systems would be employable, would be valid. And it allows, really, it proves the ability to stitch together an integrated comms network for RPAS and for small UAS operations. The activities are consistent with the ICAO ATM vision. It implies cooperation with manned aviation. It assumes that UAV or small UAV operators remote would be either stationary or mobile. And it builds security into the architecture from the beginning for safe operations. So as we look at this activity, it's a step in the direction for helping advance remotely piloted systems, enables increasingly autonomous operations, and eventually we believe it will support the fully autonomous operations that we all seek as part of this solution space. In the area of registration, this is a snapshot from our LANCE program, and in this, so you can see the yellow pathways signify the areas where flights are permitted, requiring ATC permission. The red areas are no-fly zones. The green area is an area that is okay to fly in. You can see a notification of a UAV with the letter A, and then you can see the NOTAMs provided as well as part of this. And what we're doing here is, like I think has already been discussed today, is the automation of small UAS operations for a airspace that is commensurate with this type of operation. It's also looking at the appropriate processes that would be employed in order for these operations to take place. And it accommodates the ability of air traffic control to dynamically change the airspace as required as part of their mission. We see the impact of this as mandatory to operate in the airspace. It does align with the ICAO Aviation System Block Upgrade Block 1 capability, and it supports fully autonomous operations. In the area of geofencing, once again, this is another concept that we're developing as part of the LANCE C project that we have with the FAA. It's geofencing based on altitude, and you can see the different tiers here. Tier 0 is kind of a visual line of sight with the icons reflecting the level of service provision up on top. You have Tier 1, which is similar to like an Anexa type control, where you do have a beyond visual line of sight. And then in the Tier 2 capability, you have the system is in a position to not only fly within that space, but also fly vertically as required or has agreed to with the flight plan. So with this activity, we're developing the real-time geofencing capability that would result in limiting access as required, and to be able to modify that airspace vis-a-vis NOTAMs, et cetera. It's a multi-tiered concept, as I indicated, and we see that as absolutely critical. I think we're all in agreement on that. In order for the management of unauthorized unmanned system operations in particular areas, such as airports, other critical infrastructure, et cetera. And would take advantage of, require the use of the extensive NAV database for regulators to implement a geofence solution. Okay. So let me wrap up with a couple charts here. Our activities align with the roadmap that ICAO has. We have, through the development of the beyond visual line of sight operations that we have done, the demonstrations, streamlined processes and procedures to develop the safety case, to develop the concept of operations that are employed to enable these operations. both for the RPAS and the flight vehicle. We as a company are continuing to invest in areas that we see as critical to the assurance of safe flight, security, scalability, which we think is absolutely critical and must be demonstrated, availability and latency. And all of these are focused on proving the detect and avoid technologies, and we're very active in that activity. So in recommendations, what we see is the need to maintain the level of current safety in the NAS, the need to continue experiments and demonstrations to mitigate risks, support ASBU compliance, continue to learn by doing, specific with an emphasis on demonstrating capabilities, and also to foster a favorable business environment of collaboration among aviation stakeholders to enable this fantastic capability, this fantastic technology that's on the verge of its tipping point to come into fruition and to be employed to do good things for humanity. We see that favorable business environment as critical to seeing us go forward, and obviously we're quite keen to engage with ICAO members who have an interest in leveraging the capabilities that we've done. In conclusion, the Boeing company's heritage mirrors the history of flight. And Bill Boeing said in 1916, I think a quote that I think is very, very relevant today to all of us that are in bed, are on a track to take advantage of this new frontier. We're all pioneers. And we as a company are committed to work with you, to see a safe integration of manned and unmanned systems, to employ the application of this technology in areas that will help create and shape the future, while at the same time ensuring that it is safe and enduring and adds enduring value. And as Bill Boeing also said, we are focused on building something better. So thank you very much for your time today. We look forward to your questions.
Thanks, Larry. Up next, we have Christian Ramsey, the Vice President of Business Development at uAvionix. Prior to joining Avionics, Christian was the Deputy Program Manager for Harris Corporation on the FAA's Surveillance and Broadcast Services Program and Program Manager for UAS R&D programs. He has spent his entire career in aviation technologies, ranging from aircraft and flight simulation, aircraft surveillance systems, cloud-based services, and avionics. He's a private pilot and licensed UAS pilot under FAA Part 107. Christian.
Thank you. Get myself situated here. Good afternoon, everybody. First, want to start off by, like everyone, thanking ICAO. We are likely the smallest presenter today in terms of company size. We're a small company based in the United States. We would like to talk to you today about our concepts for remote identification and tracking. We didn't take an approach of describing all of the concepts of geofencing, registration, and remote identification tracking. You'll see why once we get into a little bit about our company. But in short, we firmly believe that remote identification and tracking in particular is the key technology that enables the other technologies. If we don't know where the drones are, then a lot of these concepts fall apart very quickly. So I'm going to use the term, you'll probably hear me bounce back and forth between UAS, UAV, drones. I don't mean anything to differentiate. I know those topics sometimes mean some very specific things, so please interpret those in the most generic ways. A little bit about uAvionix. We sort of envision ourselves as a CNS system provider with a particular focus on enabling airborne awareness. Our technology focus has been on low size, weight, and power systems which have enabled us to address needs both in manned and unmanned systems in fairly unique ways. So I'll give you some examples on this screen, some of the products that we offer. In the upper right there is really our core chip technology that we've invested in. We call it the ping radio. It doesn't really have a real name. In itself is a ADSB, or in its current implementation, an ADSB receiver and transmitter. It's being integrated today into OEM units as an ADSB receiver, and you're going to see, starting in 2018, more and more UAS coming off production lines with ADSB receiver capability built in, increasing safety. We've been able to take that same core chip, which is a firmware designed radio, and adapt it to other solutions. Other solutions you see on here in the sort of in the upper portion of the screen are other solutions for UAS. We've got Mode-S transponders, we've got TABS devices, we've got 978 and 1090 ADSB solutions. The black puck in the middle there is actually not a transceiver, it's a GPS, and with that GPS for C199, it means something to some of the folks in the room. We actually achieved our first technical standard order, TSO, with the FAA. Some of the solutions on the lower half are the solutions that we're providing to general aviation. On the left-hand side are a couple of our portable solutions. Most recently, we introduced with ForeFlight the ForeFlight Scout, which is a portable ADSB receiver that has a Wi-Fi hotspot and connects to the ForeFlight mobile application and allows pilots to see other ADSB aircraft or aircraft that have been transmitted by the FAA's TSB system. The second from the left there, is it left or right? Left, yes, is a portable transmitter, portable ADSB transmitter, which is a unique standard that the UK system allows under CAP 1391, which allows for portable ADSB solutions. And most recently, in the lower right, as of 2 weeks ago, we have begun transmitting ADSB weather on the 978 frequency in the southwest of England. As far as we know, this is the first ADSB weather transmission outside the United States. So you can see that we're addressing manned aviation, unmanned aviation, ground-based receiver networks, and services that all allow overall airspace awareness. So the topic of remote identification fits right in our sweet spot of what we'd like to do. So here's the concept. The concept is that all airspace and users need a way to be aware of one another. Traditional technologies are currently serving manned aviation, those technologies being ADSB and ADCRABs or Mode-S, SSR, secondary surveillance radar systems, are addressing the needs of manned aviation. But now we have new stakeholders with the advent of drones, and we've got new needs. New technologies are needed to address the new stakeholders. We've got UAS operators, we've got unmanned traffic management systems, we've got law enforcement and security, and we've got the public. So before I get into what our proposed solutions are, it helps to state our assumptions on requirements. The primary purpose of a remote identification solution is for security. However, so from a security perspective, how can a law enforcement officer identify willingly, actively, legally participating aircraft in a scenario? This solution does not address non-cooperative counter-UAS solutions. This is an assumption that everyone is participating in a willing manner or done so through some sort of mandate or incentive to do so. However, given that primary purpose, we feel it would be a huge missed opportunity if we could not also leverage that capability for other purposes such as detect and avoid solutions. There was a discussion earlier when someone said the idea of a digital license plate. And what we mean by this is that personally identifiable information should be masked from the general public. So whether it's a registration code of whatever we call it, whether it's a DNS name or an ICAO address or something else, a registration code, that should be all that is needed to identify who the owner and operator are by authorized individuals. But the general privacy protection of from the public of the operator should be protected. Spectrum is an important consideration. Not only is this aviation spectrum, is it licensed spectrum, is it unlicensed spectrum, but also as importantly, how much spectrum are you going to use by what's your broadcast power and what's your message structure? How do you minimize this for the significant fleet coming our way in the next decade? Systems should be designed for the lowest possible, smallest possible aircraft. They're only going to get smaller. The DJI Spark is a great example of a very highly capable device that is not much bigger than your cell phone. They're only going to get smaller, so you need to design from the outset to get solutions as small as possible. Spoofing is a concern with ATSB. Spoofing, by spoofing, I mean that, folks, it's an unencrypted technology that if someone wanted to, they could broadcast fake targets into the airspace. So how do we account for that in a remote identification solution? Cost is also very incredibly important. And cost has many factors: cost of the devices themselves, cost of a subscription, cost of integration into the OEM, cost of the infrastructure, cost of the underlying database. There's a lot of cost factors that everyone needs to think about in order to enable the solution. If the costs are too high, your adoptions will be lower than desired, and if you've got half of a solution, do you really have a solution? Installation options, what I mean by installation options is you need solutions that are retrofit or stick-on capability. So add this to my existing drone right now and be compliant. And you also need solutions that can be built into an OEM aircraft platform. And finally, flexible ground infrastructure. We need solutions that can be operate both within and out of network coverage. And by network coverage, I mean LTE or 5G or internet Wi-Fi connectivity. We can't rely only on a solution that requires a network connection. Natural disasters are a great example, right? So if we have a natural disaster and the entire solution relies on a network that doesn't exist, we need a solution that works both in and out. Finally, solutions that have mobile receivers versus fixed receivers is also an element of flexibility in the ground infrastructure. So key concepts of what we're proposing here. This is my sort of takeaway slide of what it is that we're trying to do. The solution that we're about to propose, it works with or without those networks. It has some basic elements of anti-spoofing validation to it, and it's built upon existing technology. So to highlight that, so what I'm holding up here that I'm sure you cannot see in the back of the room, this is one of our existing solutions. This is a 978 ADSB transceiver combined with a GPS, combined with a altitude sensor. It's 20 grams, fully compliant. It has an FCC and FAA license to do it. So really, this is not something that is too big to implement. So, ADSB versus ADSB-like. The term ADSB, give me a second, let me catch up here with my slides. We've heard the term ADSB-like for a number of years. It appears in the NASA UTM ConOps document. It almost always comes with the quotations of ADSB-like. The first I heard it was probably 4 or 5 years ago by Dave Voss from Google at the time. The term itself recognizes the significant benefit that ADSB brings to manned aviation, but also recognizes that it's not a perfect fit. It brings air-to-air situational awareness. It brings ground surveillance capability. It brings high precision. But there are a couple of things that it doesn't do well that really don't make it an appropriate solution for a broad mass broad mass remote identification technology. So a couple of those items. There's a limited number of unique identifiers available through the existing ICAO address scheme. right? There's, I believe, 24 bits, about 16 million addresses. There's going to be more than 16 million addresses that we need to give out, so we need to expand that address space. There's limited spectral capacity to accommodate for industry projections of future UAS fleet. That's probably the biggest concern that I've heard as I've made my rounds around the world, talking to regulatory agencies. And part of that is inappropriate transmit power minimums. The standards that were set for ATSB were set for manned aviation. You can't get quite low enough to mitigate those spectrum concerns without changing standards. So ATSB-like has sort of gone by other names. We heard about vehicle-to-vehicle communications, vehicle-to-everything communications, now remote identification. The nuances between these terms, there may be nuances between the intended purpose of these terms, but the general purpose is that these devices and aircraft communicate with one another. So just to confuse things for the rest of the presentation, I'm introducing my own term, UID, Unmanned Identification System. This is not rocket science slide. There's 3 components to the system. There's airborne transmitters, there's ground-based receivers. They can be mobile, they can be fixed, and there's mobile applications. The mobile applications can be something that any UTM-like system provider provides. The surveillance data from solutions like what we're proposing can feed Unifly, AirMap, Altitude Angel, Precision Hawk, Onra Technologies. There's a lot of these system providers that we can feed with these mobile applications. So I want to illustrate the examples of how the system proposed will work both within and without a network. So this is a scenario where we've got a stadium, we've got a football game going on, and we've got an officer who is observing 2 aircraft in the air, 2 drones in the airspace, and he happens to have a mobile receiver. And what's on that graph there is the Scout that I talked about earlier. In this case, it's not an ATSB receiver, it's a remote identification UID receiver receiving the UID frequency. With this capability and a Wi-Fi hotspot, he's got a map on his iPad. He can see airspace and he can see the information that the aircraft is transmitting. In this case, it's very, very basic. It's location information, latitude, longitude, altitude, and the registration ID. Without the network connection, this is all he needs to make a radio call to a dispatch, look up this ID for me, who are these people, oh, they're CNN, okay, that's okay, they can fly. If you're in a scenario where you do have network connectivity, you do have a lot more available to you. So this is the same scenario, except items D there is a cellular tower. And with items D, you've got connections to items E, F, and G. E, F, and G can be a registration database. They can be a UTM system. They can be an authentication platform. And so you've got a lot more data on the application there that tells you this is CNN, this is John Smith, he's authorized to fly today, he has a nighttime waiver to fly. And so you can get a lot more information from those background databases if you do have that connectivity. So the solution will work both with and without. There's limited capabilities without the network, but you get a lot more information with the network. But the other thing this does is it keeps an LTE component off of the drone itself, which can help reduce overall life cycle costs. Did I miss anything on that screen? The device on the right there is what we call Ping Station. That is our fixed installation ATSB receiver. I don't have, I know the scale is not appropriate there, but it's about this big. It's a network connected device. It's a current ATSB receiver, dual band ATSB receiver, can be adopted to adapt to the UID or RID solution as well. So now I want to talk a little bit about moving from concept to what we're actually doing to make some of this happen. So in Q1, we're going to introduce a new product that we're going to call Ping ID. Ping is the brand name that we've used throughout all of our products. And so this Ping ID product is really a repurposed piece of hardware that we've already got. We take the ATSB-like concept and we shift it into a non-ATSB ISM band unlicensed spectrum. We're going to propose it's about 1 watt. It's going to give you about 2 miles line of sight. Free space path calculations tell us we should have close to 10 miles, but we've had a lot of experience with perfect antenna placement being a key factor of achieving the maximum range. So we're sandbagging a little bit by speccing this at 2 miles. It's going to have an integrated GPS. It's going to have an integrated battery. It lasts about 2 hours. Wi-Fi hotspot for configuration. This is where you enter in your registration ID. This is where you enter in your name. You can enter in the location of your ground control station if you'd like. Enter in any information that will help law enforcement understand that you're operating fully compliant. There's no host integration required for this first solution. Our entire intent is that this is a stick-on, I'm compliant, I'm participating willingly into the solution. I don't have to pull power from the drone. I don't have to integrate it into the autopilot. This is completely standalone device. There is a roadmap that involves integrated devices as well. We're going to use a TLS SSL certificate in order to try to use that system to validate the source. So the certificate will be broadcast. It will be checked against a database, and there will be sort of a general thumbs up. Yes, that guy's valid. We're not spoofing. An example of those certificates is by AirMap. AirMap proposed a solution called Drone ID, which is this very concept. It's going to be less than 20 grams. It's going to be really small. It's going to be really cool. And we're targeting a price range of very reasonable $50 to $75 price range. We're really trying to get this to be a solution that gets adopted widespread. We think the initial market is probably event management, security personnel. If you're going to come film my football game, here you go, you put this one on yours, you put this one on yours, you put this one on yours, and now I can see the three of you flying, and ooh, there's another guy that helps me point out who I need to go chase down. Receivers obviously are a key component, because if nothing's listening, then you can't track it. And I'll talk in my very last slide a little bit about the product roadmap in terms of where we see this this possibly going. I mentioned retrofit and stick-on solutions, so that's part of that overall roadmap. The next thing I want to talk about is what this UAT protocol is. So we want to start to drive the conversation around developing a standard. ATSB-like has been talked about for 5 years, but nobody's come out and said this is what ATSB-like is. So we're going to not start from scratch. We're going to borrow the UAT protocol, and we're going to modify it as a starting point, and we will expect it to continue to be modified. We're going to modify it in a few ways that make it very specific to UAS operations. We're going to expand the address space. We're going to include the TLS SSL certificate information in there, and we're going to expand it to include some content that gives some context to why that drone is flying. It so happens, and I want to call out this paper. This is a paper produced by MITRE's Center for Advanced Aviation Systems Development, who brought us UAT in the first place several years ago. They just published this paper this very week at the Digital Avionics Digital Avionics Systems Conference in Florida just this week, where they proposed a very similar concept. This is the third of three MITRE papers that have been published over the past few couple of years. The first highlighted the spectrum concern regarding using ATSB on drones. The second said, well, there's some knobs we can turn. We can reduce power, we can reduce transmit rates, and then it's not quite as bad a solution. The third paper actually introduces the concept of a third ATSB protocol and a third ATSB frequency, combined with the use of LTE networks. they've got a great graphic in there that maps by altitude and rural versus urban locations of where you'll have better ADS-B solutions, where you have better LTE solutions. By combining the solutions, you can generally cover what you need to cover. So highly recommend it. It just got published this week. I know Mike Gutierrez is here in the room from MITRE, so seek him out and look for it. We fully intend to make this an open protocol and publish it, and if some standards body wants to take it off our hands and start to drive it, that's perfectly fine with us. We just want to get the conversation started. So, because we are who we are, and we seek overall airspace situation awareness, if we produce a solution that is only available and communicated to drones, then we haven't done what we've set out to do, which is allow everyone, all airspace users, to see this. So in the air, we envision ADS-B transmitters and receivers, UAD transmitters on and receivers on drones. We actually see combination devices in the future. So an ADS-B receiver that also can receive UID or RID. And by the way, we're seeding this right now because every device that we have through portable systems and through installed systems in ADS-B manned aviation with a firmware update could see the updated protocols. And we're going to add ID and validation. So this is the protocol of how we envision a network for drones and receivers, a network for manned aviation, and how they get bridged. Okay, a couple minutes left, so my last slide, just to talk a little bit more about where we see ping ID going in the future. Future integrated solutions could include two-way communications. If we want to go down that road, if we're integrated into the autopilot, we can send it commands from a third party. We can tell it to orbit. We can tell it to hold short. We can tell it to land now. We can tell it to kill itself. Combination devices, ADS-B and RID. We can listen for a nearby ADS-B aircraft. If something gets too close, we can turn on an ADS-B broadcast so that that aircraft sees us. We call that inert and alert. So it's just a listening device until something triggers it to broadcast ADS-B. Mesh networking can be used to extend the range, and that's what the graphic is on the right. We've got, it's a little bit hard to see, but we've got an officer connected to a single drone, but he's receiving information about all of the other drones that are beyond his visual line of sight, or beyond his radio line of sight, rather, because the mesh network has repeated the information. And finally, these devices can also be little black boxes. They can record data. We can record incidents. If we've mesh networked it, we can not only record incidents, or not only record data about our own solution, we can record data about the other drones that we've heard in the area. So if there's ever an incident, we just need something that was within radio line of sight, and we've recorded data on where that drone was at that time. And that's my last slide. If you have any questions, my email address is there. Thank you very much. Thank you.
Thank you, Christian. Next up, last but not least, we have Marcello Mannino and Valerio Paciucci. Sorry. Marcello studied electronic engineering at the University of Catania. He's over 25 years of experience with international organizations, both in U.S. and Europe, in the IT field and with complex systems. He's been with IDS since 2003 as the Deputy Director of Sales and Marketing, working both in the civil and military, aviation. Valerio is the ATM and Airport team leader with IDS and is also responsible for their UTM initiative. So I'm going to ask the gentleman to join us. Thank you.
So thank you very much, and thank you in particular ICAO to give us this opportunity to present our research and development program activities. We will discuss today about what is our approach and which will be our vision as well, considering the evolving of the nature and the number of introduction of drones in the airspace. So in particular, the IDS UAT platform and as a technology enabler to provide the introduction of the safe and efficient integration of drone in the airspace, as well as the introduction of large-scale traffic on low-level altitude. So, sorry. Okay. So just to give a little agenda, I will show a little bit the DNA of the company, just to make understand how we reach faster such goal, such objective, and how we are moving through different branches also of our company to reach such goal. So IDS is an Italian engineering company that works both in the civil and military fields, has been founded in the 1980, and right now has on board something like 75% of engineer, 585 people more or less, in 5 different subsidiaries around the world, with the main headquarters in Pisa, Italy. This slide is quite important because it makes you understand how we reach practically this initiative. As you can see, we have on the lower part a common laboratory and 5 main divisions. So such 5 main divisions cover our core competencies that start from the electromagnetic application and fields, unmanned and aeronautical system, satellite communication system with KU and KA band antenna, and the air navigation division that I represent today, together with the radar system. So what we did, we create a corporate system integration where the different competencies coming from the different divisions can have a synergy, and in particular, one of these is the UTM Airport experience that cover both the radar system, the air navigation team, and the unmanned system. And Valerio is the representative of it. In terms of customers, as you have understand, we work with mainly defense agency and main brand industries, as well as with a lot of air navigation service provider, for which the reason we are here also today. And for these competencies in the fields of the air navigation service provider that we have matured in the last 13 years through the introduction of static and dynamic data management, evolving to a much more mature ATM approach on the operational concept of managing airspace and configuration, sectorization, traffic flow management initiative, that we had the ability to reach quite rapidly and conceive together a program of research and development, the UTM platform. So what we did easily is to combine such experience that we have consolidated with the AIM system in production all over the world, together with the ATM functionality. The technology as enabler, the experience with this NSP customer, bring us as well on several other research and development initiatives. I want to mention in particular, before the SESAR implementation, SESAR research and development program, in particular I4D trajectory management, EAD initiative, and in particular the latest one that is actually in yellow in this slide, that is a more new and for which we start the kickoff the beginning of October, is the REPAS introduction and exploratory research with the DREAMS project, DREAMS European IM study. So we will provide the concept of operation in this exploratory research program. In terms of context in which we are operating, let's say that we are facing in the last 5 years a gradual and let's say massive as well introduction of drones into operation. Drones that are before conceived only for military or emergency usage. Significant increase of forecasted in the next few years, and a great market potential in multiple sectors. So those are the contexts in which we are looking at, and with several benefits. So reduction of potential loss of human, in particular in very dangerous work. We know about utilities and other activities such as the fireworks, the service and business opportunity, like let's say Amazon was presenting today, efficiency and employment opportunity, of course. So those are the good part of the innovation. On the other side, we have approach on the issue, such as safety, safety intent on the ground and on the air, with the risk of collision or loss of human life on the ground, privacy, data protection, and environment. As a solution, of course, infrastructure that enable safety introduction of this UAS. So these are the key points that we have analyzed and in which we are working with our research and development program. So as a main goal and objective for the UTM initiative is, let's say, to reconcile or balance the needs coming from the ITM domain, the constraint coming from the ITM domains, and the requirement and challenge of the drone industry on the other side. As a need, we have a safe and efficient integration for large-scale drone into the low-altitude airspace. The goal of obtaining existing constraint limitation on the airspace access, and to reach a full exploitation of the potential US operation in a cost-effective and operational way. So the key enabler for, let's say, this, the key enabler for this activity, of course, of introducing the BVLOS operation and autonomous operation into service. So what we have understand and what we have somehow summarized, these are 3 pillars, like the one set up for the IM from ICAO SBU, relevant to drone regulation and standard, SOS capability and technological maturity, UTM services, enabling infrastructure that could be our IDS UTM platform. So now I will leave the floor to Valerio that will go through a bit on our solution. You can see some of the screenshot of the system in the slide that Valerio will demonstrate. Thank you.
Good afternoon. It's a great honor for me to present our IDS approach on UTM in order to contribute to the safe and efficient integration of drones, small drones in very low level airspace, and to increase airspace access possibilities in this portion of airspace. Our approach is based on the implementation of enhanced airspace management and dynamic data management capabilities with information sharing capabilities, in conjunction with the adoption of a best equipped, best served principle. In order to face the new UTM challenges and in order to contribute to the evolution of EU space, for example at European level, services, and starting from the UTM, NASA ConOps, taking into account also the evolution of EASA regulatory framework, and taking into account also the overall architecture of UTM within the GUTMA initiative, our approach is based on a parallel implementation. On one hand, we have the implementation of basic capabilities and services to support the stakeholders for a real short-term implementation of basic services, and on the other hand, at the same time, in parallel, the implementation of enhanced capability to allow us to collaborate with UTM stakeholders and for example, the definition and validation of new operational concept, new requirements, and new recommendation within UTM. Our system under development is called DREAMS, Drone Enhanced Airspace Management System. It is conceived to be a system that covers all the phases of flight of UAS operation, starting from the strategic one up to the post-flight phases of flight. The system is based on the same, as Marcello already said, technological infrastructure of our air traffic flow management solution, and is conceived to enable the major stakeholders, civil aviation authority, air navigation service provider, private very low-level airspace service provider, and major UARTS operator to implement UTM services, for example, flight planning, notification, tracking, and management of UAS operation in general. The system implements a set of tailored services and ad hoc interfaces for different kind of stakeholders that can interact with the system. In the picture, just some high-level capabilities of the system are shown, starting from the registration capability, flight planning and validation capability, flight tracking and notification services, up to preliminary implementation of airspace occupancy calculation capability and demand and capacity balance for complex scenarios. The system already make available a set of functionalities that support UAS pilots, recreational users, UAS operators, for example, in terms of registration of drones, flight planning, access to reliable and up-to-date ATS geography and no-fly zone data, and is implementing also some specific notification services in support to very low-level managed space users such as Ames that, for example, can have a benefit in receiving notification in case of planned flights within their typical areas of operation. Other functionalities are in part already available, in part under development, supporting other potential stakeholders such as law enforcement and civil and aviation authorities, for example, for the creation and definition and submission and validation of no-fly zones, or for example to access to traffic data for post-incident or accident investigation, for example to verify if a violation has been occurred during the conduction of a flight. As I said, the system support all the phases of flight. In this slide we try to map the DREAMS implemented and under implementation functionalities with the phases of flight and with the several service levels that have been recently defined at European level within the U-Space concept. As I said, not all these functionality are already available, as we see in the following slide. I prefer to start from innovative functionalities conceived, supervisioning functionalities conceived to support an UTM supervisor for which currently no specific requirement exists, that that can be supported by the following information, for example, implemented within a specific dedicated dashboard. For example, the real-time information about airspace occupancy, current and in the future, estimated in the future, starting from the amount of flight planned drones operation, and this information is provided at different levels, geographical level, local level, regional level, state level, and so on, depending on the specific type of implementation. The UTM supervisor is also provided with occupancy warning in case, for example, of overcrossing of pre-configured capacity threshold of the traffic demand. The supervisor is also supported by multi-layer that can be activated and deactivated, related to meteo information, flight plan considering their status and typology, no-flight zone visualization, and so on. Other capabilities are, for example, the possibility given to the UTM supervisor to search according to specific criteria through fence or through free text specific flights to have all the detailed information in real time. This UTM supervisor can be notified, for example, in case of publication of new no-flight zone, and is warned about in case of infringement of a flight in a non-authorized airspace. The system currently implement the validation of flight plans in terms of airspace constraints and taking into account national regulations. Give the possibility to request specific interaction check with other planned flights, and give the possibility to a UTM supervisor to, for particular type of operation, to approve or reject the flight after the validation automatically performed by the system. Other functionality is implemented within the system are, for example, the definition, submission and validation of new no-flight zone, the possibility for the operator to request an impact assessment of the new no-flight zone on already approved and planned flights, and so on. Other capability implemented mainly conceived typical functionality to support UAS operators and pilot that can be used or directly through the web interfaces provided by the system, or through an API mechanism provide all services to external system to interact for flight logging, flight plan validation, notification services that are available also to external users. A part related to the drone registration and unique ID assignment is already implemented. We included also the automatic generation of QR code provision, and the system includes also a catalog of drone and several manufacturer models. Within the system, there is a multi-platform mobile application that is under testing that provide the functionalities listed in this slide. And now just some information about the technological and development approach that we adopted during this ongoing implementation of the system. As I said, the system is based on the same technological infrastructure of IDS Air Traffic Flow Management Suite. We implemented a microservices infrastructure in order to guarantee in a very dynamic scenario high level of scalability and high availability requirements. is swim-based. For the moment, the system implementing aeronautical information exchange models. For the development approach, taking into account the changing nature of UTM and the need of changing the prioritization of the implementation of new functionalities and so on, we implemented an agile Scrum process with the duration of the sprint foreseen within this kind of development process of 2 weeks. We used open data format and open standard for web services interface. The system implement a self-documenting API capability that provide all the detailed information to interact with the system to external users, and a continuous integration and deployment process has been set up that allow the automatic quality check at all the phases of the development process that allow the quick release of new functionalities. Okay. The last one. Okay. So in this slide we try to put on the table other possible common framework element that can be properly addressed in R&D and innovation project, in addition to the already shown capability under assessment. For example, all the aspects related to the NOTAM management for what concern generation, NOTAM proposal, NOTAM approval, and how this concept can be applied to the new UTM context. The capability for what concern flight prioritization mechanism, taking into account, for example, particular privilege or drone characteristics, capabilities related to the generation of alternative drone flight path or rerouting capabilities, all the aspects related to the interaction and coordination with the ATM and ATC, and in particular for what concern notification and authorization process to protect sensible infrastructures such as airport, and the acquisition and management of ATC tracks to improve situational awareness within the UTM context. That's all. I hope I'm in time. Okay. Thank you for your attention. Okay.
Well, thank you very much. We're just going to have not a pause. I'm just going to invite the speakers from this morning to join us up on the stage here. We've got some chairs available for you, and once you're up here, we'll start going through some of the questions that have come in. It's like a game of musical chairs. We're short one nice chair, so we're going to. I think ICAO will give you a special prize for having the lone non-comfy chair. What I'm going to try to do for the first questions, we've been receiving questions, and if you do have more questions, I'll try to filter them as they come in. But we've had a number of questions that came in that I would kind of group together around questions of reliability, questions around have you thought about contingency plans, failure cases, question around what about you're using unlicensed spectrum, and you know what is that? What are the impacts of say the volume or conflict in around spectrum, and even reliance on perhaps third parties for 3D mapping and obstacle identification, just generally questions around the reliability of what's being proposed. And so I'm going to throw out, I'm going to ask Gertie, you to start, because you talked about certification and testing. It's going to be a two-part question. I want to hear from people in terms of what should our expectations be around reliability across those issues, and then what does that mean in terms of cost? Because another one of the questions that came in that talked about some of the mandates in some states, for example, is to say if you're going to put ID technology on a drone, it's 10 grams for 10 euros. So how are we going to reconcile a certain level of reliability with a certain level of cost?
Sure, thank you. That's a fantastic question. I'll start with reliability. My basic premise and sort of the way we've been running our project is that we're making our vehicles independently safe. And I let it sink in. When you think about an airplane, you know that the system is going to be safe because if everything else fails, there's still a pilot and they're still in control. They have situational awareness. They're going to do the right thing. And of course, that doesn't work in all meteorological conditions. Now, that gets us into detect and avoid, and demonstrating the detect and avoid can operate in all meteorological conditions. With that assumption, the burden of demonstrating robustness of the system shifts from the infrastructure to the vehicle. Of course, that's a spectrum. There are other types of vehicles that won't have as much capability. I think our project potentially should be serve as an example that this technology is possible, and encourage everybody to go deploy it, and it's completely feasible today. But I'm also sensitive to different needs. You may have a lower equipped aircraft that operates in a low risk environment, and you have a highly equipped aircraft that operates in a much more complex environment. The trick, of course, when you have an independently safe robot, flying robot, aircraft, drone, whatever you want to call the thing, is that there are no unknown unknowns in your ConOps. For every off-nominal or emergency situation, the vehicle will pick the correct safe decision, which at some extreme situations, the correct safe decision may be to ditch in a lake. That's safe. It's not safe for the drone, but it's safe for everybody in the airspace and around it. And that's the point that we have to certify. These are the standards that we have to develop. They begin with ConOps, they begin with equipage, and then they end with certification. On the matter of cost, I think a lot of the cost relates to enforcing a certain type of technology. And I think whenever we can solve for cost using technology that either already exists, or is software versus hardware, or is performance versus functional, so we keep ourselves open for future capabilities, then cost can be maintained. We sort of have a unique perspective, being both a designer, builder, and operator. And I can tell you sort of my own experience that cost is not a concern. It would be a big concern for me if it was, right? Because I buy for myself to to all practical purposes. We are not talking about the cost of traditional or current aviation. These are much simpler systems, and they can be built in a very robust way.
I'd open that up now to some of your colleagues, other panelists who'd like to speak to this. Oh, I thought this was going to generate all sorts of...
So is it on? I'll speak quickly to the cost associated with reliability, associated with certifications. So as an avionics company, the certifications required can be quite high. I mentioned that we have a TSO. A TSO is the process you go through with the FAA to prove that not only does the system perform in the way that it was originally intended, but it also was developed in a manner that was prescribed. And that development in particular is a very high cost, and proving the quality of the development process is a significant cost. There's been a move of late to move towards performance-based standards, and I would say that whether performance-based, whether quote-unquote TSO is what is needed for flying equipment in the future, performance-based standards is certainly the right way to certify or qualify, might be the right word, equipment. Don't be prescriptive in how you go about doing things, because that stifles innovation. Just tell us what it needs to do, and with the performance parameters that it needs to do, we'll come up with some tests that verify those performance parameters, and that will bring the overall certification and developmental costs way down, and those costs would get passed along to the end users.
Any others for this particular question? Yeah. Oh, well, we'll go down to the end, and then Larry will come back to you. And I think we've got a...
Thank you. The problem of qualification, or the let's say the cost of the system, we speak about certification, but let me express an idea that we're speaking about small US, so with a sort of limited impact, in any case limited impact, even if we have to take into consideration if you fly over the people or crowded people, that the impact can be lethal or can be serious injuries, so we have to take care of this. So of course, for such a kind of drones, it's almost impossible to write any rule unless requirements, I mean 10-year requirements, 10-year end operational requirements that can be prescriptive, or let's say that will link to a specific technology. This is impossible, and we cannot certify in accordance with the standards that we know in the aviation. So till now, the approach has been so-called operation-centric, just in order to take care, or let's say to take into account the level of risk or safety of the machine that can be alleviated and mitigated by the other components, the pilots, the procedures, the on-ground equipment, geofencing, and so on. But the costs should be limited to the complete system, an integrated system for a smaller US, because there is no chance to approve or certify. Also because the technology is so fast that you will change every day, and it's not possible to track through a normal, or let's say traditional certification process, this kind of drone. But for the let's say performance-based requirements, or let's say performance-based objectives, can be possible to, in any case, to give some safety features under control. Just to make an example, we don't know anything about the reliability of the engines, or the duration of an engine, the linkage between the various components. So there is nothing prescriptive in this sense. So we have to go through better practices, the best practices, industrial practices, and trying to focus on very limited safety concerned systems.
Larry?
Just two brief comments. So we would agree that both for on the safety side, a risk-based approach is coupled with performance is critical. We think that's the only way that you're going to be able to put some parameters around how the risks and the liabilities associated with the services that would be provided that can be managed. So we think that those two areas go hand in hand.
Thank you. I like the comment on not being prescriptive. I think one way to think about it slightly differently, if you will, is we tend to think about cost based on our own history. We look at the last 25 years and we try to extrapolate what cost should be. This is new. We can be inspired by what this room has created and the services we enjoy every year, but the technology is different. And the rate of innovation, the rate of improvement, both in capability and scale and cost, is extremely rapid. If you thought about, and I think that just consider your cell phone as one example of a cost driver. Think about the capability, the functionality, the performance that you have in your pocket right now, and go back 5 years or 10 years. And 10 years ago, if I ask you what kind of mobile device will you have, how cheap or expensive, well, depends which vendor you buy from. And, this week, right? Sorry, I love my Apple device. But when you try to sort of try to project forward. Don't project backward, because if you project backward, then things look very hard and very expensive. If you project forward, then you really are focused on that rate of innovation, and the rate right now is the highest I've ever seen. So the cost that we're aware about today, we will not be worried about in 5 years. And we want to design a system that will be cost-effective in 5 and 10 years, not today. That's a fundamentally different way of thinking about it.
If nothing else on this question, a number of you kind of touched on, and I'm going to be selfish here as the regulator up here to learn a little bit more from you. Some of you already touched on this, but again, I think it's something you could all elaborate on is, what do you need from ICAO, or what do you need from regulators to make some of this happen? That's the positive way of asking the question. The negative way would be, what don't you need? How can we get out of your way? So throw that out to whoever wants to start on that one. Any thoughts? There, you got the mic, Larry, you go for it.
One thing that I would think would be really helpful is that as we're all learning by doing, how do we collect all of this knowledge in some location so that we all can learn from the experiences, both good and bad, that have taken place, so that we can go forward faster by having this knowledge in some sort of a central location.
It's back. I think uniformity. Driving and convincing, and sometimes, as necessary, enforcing uniformity to make sure that we have the same set of standards that work worldwide is what's going to create this industry. We had data communication networks in the 60s and the 70s and the 80s, and it was only when the internet was standardized and everybody implemented the same standards that the market actually happened. That is a role that actually is unique to this room. You guys can drive it better than anyone else.
I think
it's a very... Can you hear me anyway?
maybe you may even have your own personal mic.
Okay. Hello. Okay, technological problems.
That's why we want reliability.
What do we need from ICAO? First of all, a mic that works. Yeah. Definitely. I think that this event is a clear event, is a clear example of what we can need. Is an open forum for which we can discuss and share ideas and proposals and visions. And the idea of the toolkit that I saw in the app, I think is also very interesting, and is possibly answering the point that the colleague from Boeing was making up. So I think these are very positive. What we cannot afford in this particular environment, I think, is the standard process which we are used for in aviation, because the speeds are not comparable, and this technology, the drone technology is more driven by IT rather than aviation evolution. So it's definitely not possible. So I heard, and we might discuss this in our global UTM association, there might be a proposal from ICAO to have to be the single worldwide registration entity for all drones. I think this is something that we do not need. So you ask what you need, what you don't need. I think that could be an example of what we might not need from ICAO. I think we need to grow up locally and put together and drive the standard evolution and be clever, so that our development, we don't want to wait for the standards. We need to go ahead, but we need to develop our local platforms in a clever way, so that after all, it will still be possible to adapt to the standards when the standards will be available, because certainly standards will be the key for full interoperability.
I'm going to ad-lib a little bit here and just take, because at least I heard almost contradictory answers here. One was we needed a common approach. The other was we needed local approach that would grow organically. Am I wrong? Are those contradictory, or are they?
Maybe I was not clear enough, and that's my fault.
I'm trying to provoke a discussion, so
sorry,
I'm devil's advocate.
I think that we need a common environment to discuss and share, because we also have an habit, especially in aviation world, or maybe it's a common approach from human being, which is to reinvent the wheel every time. So that's something we might not need. We can leverage on the best experience here and there, and get the best and import it. And that's the arena where we can share these ideas and best practices.
Anything else on this one? No, Christian.
So I like the idea of harmonization. I like the idea of guidance. What I worry about is inserting traditional standards, aviation timelines. So in terms of what we do not need, industry is already moving faster than the regulators can regulate, and that's in individual states. If we now introduce an international body that the regulators need to coordinate with one another, we'll never ever get there. So it's the challenge to ICAO is how to enable the harmonization and enable the information sharing without being a blocker any more than the regulators are trying not to be blockers now, right? So that's what I would take away from it.
And one of the questions that came in was, what can we learn from other industries? I think a couple of you alluded to, for example, the automobile industry and how they're bringing in automated and autonomous vehicles. So I'm going to throw that out, but I'm going to also ask you then, what can regulators, aviation regulators, learn from how other industries are regulated or not regulated? So two parts of this question: what can we learn from other industries that are embarking down a similar path? But also, to the extent that those other industries are regulated, are there lessons learned for us as a regulator?
So I think there's a couple of examples. One is the communication revolution with IP that happened in the mid-90s. And I think it was a great example of the ITUT, who's like many bodies who are very serious and take they're doing incredibly important work, can be slow, turn around and created a set of standards that were harmonized globally and liaised with local standard bodies within 2 years. That used to take 15 years to get anything done in international telephony. It was done in 2 years, and the same standards were available for local use, international use, reconciliation, and actually using a very similar architecture to what that we're talking about here. So there are examples of a body such as ICAO moving fast, and I think that's an inspiration that you could use. I think from a regulations perspective, it's inevitable that this will be a certified, i.e. regulated space. It has safety implications that if we don't do it well, there are positive effects that are fantastic, and there are negative effects that we want to control. We also have a very safe NAS, and we want to maintain and improve the safety of that NAS. I think we may get away with short-term segregation, as some people mentioned earlier, but I think everybody should agree that full integration is where we want to end up, and we don't want to take too long about it. And that requires sort of a more direct and directive, I should say, approach. But the point around leveraging industry capabilities is absolutely on point. There are a couple of other industries, self-driving car and smart cars, if you will, smart grids, smart cities, where the technology they've developed is designed for safety applications. Right? If my car has to do an emergency braking situation against another car, and they use a V2V protocol or V2X protocol, and I use V2X to get weather traffic to tell me that I can't fly, that I can't drive as fast because the road is slippery. These are critical life safety applications, and they are being deployed in other markets. Can we just use it? And of course, I think that the important question is what questions do they answer? And I think maybe I'll mention that this relates to ICAO specifically. One of the one of my observations, it's very hard to know what questions are in your head that we need to answer. If I can represent sort of industry for a second, I don't know about all your concerns. But if it's possible to create a dictionary of all your concerns, all the questions, all at once, and then as a sort of as an industry, divide and conquer and go answer all your questions, then suddenly we can move fast. And I think that's actually an activity you guys should take on.
I'm going to pass that one over to ICAO then. Please, yeah.
Let me. Your question is very provocative. What a regulator can learn from other sectors. Let's say that in the aviation field has been till now, it is one of the most regulated industry and activities today that we have. Maybe the nuclear one, the aviation. Other activities are less regulated than the aviation. And the aviation has regulated itself as in its own world, with its own rules, and it seems to be a closed world where for anyone it's difficult to enter. Till now, there are some, let's say, some very basic results and goals. The safety has been really a driver to produce such a kind of or perceived closed world. But we don't have to forget that we have built a safety on the accident and on the thousands of deaths, and it makes a difference between the evolution that we have and in other sectors. We can have some failure in the banking system. No one will die. So you will lose money, but we will not die. So there are basic differences between aviation field, other fields where the safety is of paramount importance. But let's say that we are learning because and this forum is a clear demonstration. Any regulation we have produced locally, either locally or at the regional level or at the ICAO level, are changed completely the approach. So for the drones, for the small drones, no one of us is thinking to, let's say, to proceed in the traditional way. So we are learning from other side and from other sectors where the, let's say, the evolution, the technological evolution is guiding the progress. And I think that in this field, as has been said, IT specifically will lead the progress in the sector. And the industry will play a role in progressing. So I think that we will be able to produce very limited performance-based and limited regulation. So the principle of use it, let's use it, any best practice that will come is a good approach. And I think that we are learning, and this is a learning process that we are into.
Go ahead, Gerd. Yeah.
It's back. I think one I wouldn't call it an issue, but an observation is a matter of taxonomy. We say aerospace, but what we're actually talking about is a robotics field, right? It's some of us have spent their career doing robotics. I think how we treat robotics, both in terms of standards and compliance and certification and performance and interoperability and harmonization, is beyond aerospace. I get asked often the question that I'm building flying robots, and am I worried about it? Is it hard? Is it easy? How is it to do that kind of engineering work? And I think my observation is that the most successful robots in the world today are the airplanes that you guys operate. They're already mostly roboticized. Right? I read, there was some research that I read that says commercial Part 25 aircraft to this point is managed or controlled somewhere between 3.5 to 7 minutes during a flight. The rest of the time, it's the world's safest robot. So this industry can learn from robotics and self-driving cars is another example, industrial automation is another example, but also can teach other industries how to build safe robots. So I think that basically information sharing can go in both directions.
So, it's interesting. As I listen to the presentations, we're kind of we're trying to vector in on some solutions. We're coming from different perspectives. I certainly noticed a degree, if you will, in terms of how important automation was going to be, and that generated two questions. One, and actually three questions probably. What's the role for pilots in a UTM of the future? What's the role for air traffic controllers? And then what about the unlawful, the person that doesn't participate, the non-cooperative? So again, it's around to what degree do we depend on automation, and what does that mean for the pilot, the ATC, and what impact does that have with the uncooperative or the unlawful player in the field?
Thanks. It's a very interesting question. I think, well, pilots will disappear in a certain way. We use the term pilots in order to, let me say, feel more confident about drones. But pilots already, they are not piloting the drones themselves. They manage them somehow. They set up a plan, but the drone flies on its own. So it's not really piloted as the way we intend piloting, like keeping the wheel driver, the steering wheel in your hands. It's not that case anymore. And this is going to be disappearing more and more when we will move to BVLOS operations and ultimately to autonomous operation. I cannot think of Amazon Prime Air working with one pilot per each drone flying and delivering parcel. It will never be a business case for this kind of model. So pilots will somehow disappear. There will be few fleet managers from Amazon, few UTM supervisors from the UTM service provider side. We cannot afford a system as the one we are supporting and affording for air traffic management. We do have, I don't know, 3,000 controllers for the Italian airspace. We cannot afford 3,000 controllers for UTM, or we can forget about the 3,000 controllers taking over the million of drones we are expecting in Italian airspace.
Sorry, I'm bobbing back and forth, so go ahead.
Well, just a consideration, even today, if you look at the more advanced commercial aviation, we have a different, let's say, content of the professional of the pilot. So today commercial aircraft are able to fly, to land, and of course even to take off without any human intervention from the technical point of view. So the pilot is already, let's say, experiencing a change in the content of its own role. So of course, we are speaking about a small US, so it will change completely, and we have to speak about managing the flights or intervening in the case of disruption on the operation.
Anybody else on that? I would ask you to reflect a little bit, and again, I'm hijacking a little bit, but that's what I get to do as the moderator. We've brought in new regulations, and one of the biggest, or we're in the process of bringing in new regulations, and one of the biggest communities that we're hearing from is not up here. It's the recreational user, and they want to fly, and they want to fly in all sorts of places. So that question is, in some senses, directed to them, because they're not going to be part of one of your systems, but they need to somehow plug into it. Can they?
If we make it affordable, absolutely.
Sorry?
So if we make it affordable, then absolutely. So let's make it affordable. Look, there's a place and a time to operate hobby type, AMA type, if you're in the US, aircraft. And they have private flying fields. They can be geofenced. You can go to the field and do whatever you want. This is functionally equivalent to go building a race car that is not road legal and going to race it on a racetrack. You wouldn't consider taking that car and driving on a highway. It wouldn't be safe. And again, if we make the equipage to interoperate cheap, inexpensive, affordable, scalable, lightweight, low energy, all the important verbiage that we have to make it, then when they do actually want to take their vehicle and integrate it, then they will be able to. But they absolutely have a role that's not going away.
If I may compliment, we need to distinguish, because there is a big let me say, a set of people which should definitely belong to the recreational people that want to, the recreational part is flying. It's not taking photographs or shooting videos. They want to fly, and they will not fly a drone, because I do have a drone on my own, and I find it's boring. There's no recreation in flying a drone. Sorry about that. He flies on his own, so there's no skills. That's the success of a drone, by the way. Yeah. The drones are successful because they are so damn easy to fly that you don't require a pilot. You just need an iPad or an iPhone to drive it or to plan his mission. The recreational pilots, we still do recreational piloting of real aircraft, for which, if you are not good enough, you will smash it on the floor. So, and
anyone else on that one? I'm glad I'm provoking a bit of a reaction. That's good. Oh, Larry wants to get in on this.
I agree that drones can fly themselves, but the fact is that people need to understand the rules in which those systems can be used. There are too many instances today where you see drones approaching aircraft, or drones hitting aircraft, and either by neglect or intent, those things do occur. So people who are individual users are part of a community, and they need to understand their responsibilities as part of that community so that they fly appropriately. I mean, it reminds me of a story a friend of mine once told me. He was living behind the Capitol in Washington, and they'd heard a helicopter outside. And the kid next door had a drone, and he wanted to get the drone, and he was saying, "Hey, Dad, there's a drone up there. I'm gonna take it and send it right up there." And my friend counseled that that probably was not a good idea. But that's the idea here, is that there is a need that all operators need to be responsible. Now, there may be a point in time when the ubiquitous airspace is controlled in a way that anyone who doesn't understand the rules would be prevented from doing something stupid by some sort of a geofenced environment. But we're not there yet. So in the meantime, I do think that the individual users need to, as I think ICAO and other regulators are trying to do, to educate the public on their use, to ensure that that manned flight is not impacted in any way, shape, or form.
Brian Wynn this morning made a comment that this is going to draw in the next generation of pilots, the next generation of aviators, and that term will change. But also don't forget that this technology is going to migrate upwards into manned aviation. I think manned aviation will still exist ultimately as a recreation itself, right? So maybe unmanned freight or unmanned passenger aircraft are somewhere in our future, but can you imagine having small detect and avoid radars on your Cessna 172 and really cool autopilots? And this technology is going to migrate itself into aircraft and make manned aircraft, recreational aircraft, much safer. I think about the auto braking technology on some of the cars now. They detect someone and they hit the brakes, right? That same concept could take over the controls of your Piper Cherokee and avoid something, right? I mean, so there's huge opportunity for that technology to move upward and not a replacement. So.
I have a couple of questions that come in around liability. So it becomes a question of who's managing this and where does the liability exist when an accident, hopefully it doesn't occur, but when it does occur. So where does the liability rest? Is it with the regulator who has regulated the system? Is it with the service provider? Where does the liability rest? And the product as well, in terms of what we're talking about with it. So, anyone want to take that? No one wants to take. The legal departments want to take that one on. Go ahead. No?
It's an issue, certainly for, as we look at this environment. We're a big company. We have big pockets, and certainly in the U.S. environment, when accidents take place, they tend to come looking for those with the deeper pockets. So, as in our particular environment, as we look at how do we engage in this technology and advance it, we are governed by the concerns of liability, and so I would think that the idea of some sort of, as this technology matures and develops, some sort of a limited liability type environment is probably conducive to ensuring that the industry can take off and develop the track record that's required in order for the risks associated with operations are fully understood and managed accordingly.
It is not an answer because it's difficult to answer, really. But let's say that there is a situation in which anyone can be liable if in a given situation where the technology exists, some tools are available, the state of the art is, let's say, defining some line under which you are unsafe and above the line you're considered safe towards the state of the art at that moment. If this is the situation, and if the liability can be measured against such a kind of parameter, I think that the regulators can be are liable if or unliable. Well, the liability of the regulator, let's say, can be expressed in the sense that if you know the state of the art, you are knowledgeable, and you don't know anything to give to the general public the right level of rules, transferring the state of the art as something that has been a baseline for the safety, I think that we could be considered liable for this. And same for the design, the architecture, and the system to fly safely at the level at which the technological development and the state of the art can consent. So the single operation, if you have provided the system with the right regulation towards the state of the art, the right architecture, the single operation can be, is on the shoulder of the operator, of course. So the liability, let's say that the liability, in my opinion, can be explained in this way for the time being.
Go ahead, Christian.
I think it's a question that's actually bigger than our industry. We're entering into an age where artificial intelligence algorithms are making decisions. Now they're starting to make safety decisions. I'm fascinated by self-driving cars, and if they're forced to make a decision to save the driver, occupant, or a pedestrian, how does it do that? And when someone gets injured, there will be lawsuits, and who is ultimately held liable for that decision of that design, of that AI's algorithm? And it's a similar concept here, just in the air, right? So I don't think we can answer it yet.
I like that answer. We've got time. I'm going to suggest we've got time for one more question. Oh, and I had two that I wanted to ask. So if you guys are really quick, I might squeeze another one in. A lot of questions came in about cybersecurity, both in terms of what you may already envision or what you think is required. So just if people want to talk a little bit about the cybersecurity requirements here, because it's not always it's a dangerous world out there, we'll say. So, yeah.
Yeah, I'm picking the hard one. Look, this is important, but I'll actually note, and again, this is no criticism at all of the existing aerospace industry, but ATSB today does not have any security. And that was mentioned by one of the speakers. I can stand in a core like next to an airport and inject bogies into the landing pattern and cause all kind of issues. So we sort of are living with cybersecurity issues right now. How many laser into the cockpit, there's a technical term to it, I think it was 3,600 in the US alone just last year. So lots of events that are taking place. Pilots were blinded, well, temporarily blinded during landing. So these issues exist right now, they're not new issues. Given we're building something new, we can start using state-of-the-art security from day one. We don't have to build something that's insecure and then retrofit security into it later. Let's just make a decision and define the requirements that the system must be secure from day one. That's where we should start.
Let me just make a consideration. Of course, we are living a period in which the threats are every day on the newspaper, and every society is attacked every day for many reasons. And it's not the case to go deeper into the motivation, of course. But it is a matter of fact that cybersecurity has today a visibility in any political at any political level. I want only it's not a joke, but we are under the pressure of the protecting from the digital point of view. The drone, or from any attack, or any, let's say, to let him secure, fly secure, and not so only safe. So we are is a run between. We try to protect the drone not to be kept by any other ones in order to be distracted from his own trajectory in order to be used for malicious use or for a terrorist attack. On the other way, we try to discover any means to get the same thing when you have an attack. So we have to protect, but at the same time, we have to try to have tools in order to, the spoofing is not considered a good way, but from many points of view, from many aspects. But the police, let's say, they tend to gather the enemies, the drone used for terrorist attack, that has been protected because we are protecting the drone from the same thing. So is a circle. There is not is a visual circle, let's say.
One final word. Does anybody want to? If not, first of all, I'd like to thank those of you who sent questions in. It made my job a lot easier, and apologize. There was a lot of questions that we weren't able to get to, but I think, and some of them were directed to individual panelists, so we'll share those questions with the individual panelists, and they'll get back to you, hopefully. More importantly, I'd like to thank each of you. This was, for me, a very fascinating day. I really appreciate it. I could actually spend another hour, I think, up here talking with you, so I appreciate your time and your energy and your insights. So please join me, everybody, in thanking our panelists. Thank you. I guess
So again, thank you to the panelists. It has been absolutely fascinating. And Aaron, well done. So we have another coffee break available. I would ask that you all be back here at 5 o'clock, 1700, and we have just a bit more to get through for today, but a bit more very useful information to have. Thank you. Enjoy your coffee break.